Welcome back to my session Matrices. Today we are going to discuss a very important topic in matrix, which is operation on matrices, which is multiplication of matrices. To understand it in a proper way, I have taken example of three matrices of different order. You can see this matrix of order m by n, second is of order n by p, and third is of order p by q. Here one question arises: when multiplication is possible, can we multiply all matrices, or there are some conditions? So let's say if you want to know whether multiplication AB is possible, so I am giving you a very interesting trick. If you want to know whether AB multiplication is possible or not, you do one thing. First, write the order of A, which is m cross n or m by n, and write the order of B, which is n by p. You have to check one thing, that is, these two numbers must be same. When these two numbers are same, we can say multiplication of matrices are possible. And when we delete these two numbers, we will actually get m and p. So the final order of matrix, which is actually AB, will be m by p. Similarly, if you want to know about BA, so you write the order of B, which is n by p, and write the order of A, which is m by n. We can check here that this p and m are different numbers, so we can say that BA is not possible. Similarly, if you want to know about AC, write the order of A and write the order of C. Again, here these numbers are different, so we can say AC is not possible. And finally, for B into C, write the order of B and write the order of C. Here we can see these numbers are same, and the resultant matrix order is n cross q. So BC is possible and its order is n cross q. So finally we can conclude that multiplication of two matrices is only possible when number of columns of first matrix is equal to number of rows of second matrix. Why I am saying this? Because if you see here in BC, its order is n cross p, so it means for matrix B, this is row, this is column, and for matrix C, this is row, this is column. So it means when column of matrix B, which is first matrix, is equal to the row of matrix second, which is C, if column of first matrix is equal to row of second matrix, these are same, then we can say that the multiplication is possible. Okay, I hope it is clear. Now one note here, suppose you are multiplying two matrices A and B. So first matrix is actually known as pre-multiplier and second matrix is post-multiplier. One more thing is about product of matrix is like when we multiply two real numbers, say 2 and 3, so we can write 2 into 3, which is 6, or 3 into 2, again it is 6. So we may say that the product of two real numbers is commutative, means we can multiply in any order, we are getting same result. But here in case of matrix, it is not always correct. So that's why you must remember this fact, that if sometimes AB is defined, then it is not necessary that BA is also defined. And one more thing, if these two matrices, say A and B, are square matrix, then both AB and BA are defined in this case. So this is only correct in case when we see कि these two matrices are square matrix. Now next question arises कि how to multiply two matrices. Actually, multiplication of two matrices is totally different technique. So here I am going to tell you a very interesting way how to multiply two matrices. I have taken two matrices which is A and B. Say these elements are given by A11, A12, A13, A21, A22 and A23. Its order is 2 by 3 because it has 2 rows and 3 columns, and matrix B has 2 columns and 3 rows. That's its order is 3 by 2. So I have enclosed this row which is first row. Say it is R1, it is R2 and it is C1 and C2. So this method says if you want to find out AB, because here AB is possible because second number of first matrix which is 3 and first number of matrix second which is 3 both are same, so we can say that multiplication is possible and final order of AB will be 2 by 2. So okay, so how we will initiate, we will do, I have written a shortcut sigma r1 c1. What does it means? It means we are multiplying corresponding elements of row number 1 and column number 1, and when we will add we will get a single element. So that's why I have written sigma r1 c1. We will discuss in next step. Similarly, this row 1 will be same and we will do the same operation with column number 2. So I have written sigma r1 c2 and all the product will be added, we will get a single element. So you must remember, when we initiate we will take first row of first matrix and then we will take all the columns of second matrix and we will form a row, correct? Similarly, you can see here, I am taking row 2 and this operation will be done with column C1. So R2 C1 sigma, which is addition. Similarly R2 C2 sigma, and final order will be 2 by 2. Say here I have mentioned how we are getting this. Just see, uh, you can see here this A11 B11 into plus A12 B21 plus A13 B31. So when we are adding, so that's why I have written sigma. So this is single element. Now apply the operation again. A11 B12 plus A12 B22 plus A13 B32. Here I have written and you add it. So what we are doing, we are multiplying a single row with individual columns of second matrix, correct? And we are getting a single row. Again you can do, which is A21 B11 plus A22 B21 plus A23 B31 addition, you see here. And finally we are getting in this way A21 B12 plus A22 B22 plus A23 B32. So in this way we are getting a matrix of order 2 by 2. And I have made a chart, a small chart type. This is row of first matrix and these are the columns of second. So you must remember this technique ki we will take row of A and all the columns of B and we will form a row. This row will be of matrix AB. Right, now come to the properties of multiplication, which is very important. And first property of multiplication is associative property. Suppose there are three matrices and we can say here the multiplication is possible then either you multiply A with B and then final result you multiply with C, or you can do one thing, you first multiply BC and pre-multiply with A, so you will get same result. Okay. Second is distributive over addition. What does it means? It means two matrices are already added and we are multiplying by a matrix A, which is pre-multiplication, right? So we can distribute this product over addition, means we can multiply A with B and plus A with C. Similar case here, AC plus BC. Second property is multiplicative identity. Multiplicative identity means, suppose in real number I have 1. So if I am multiplying 5 with 1, we are getting same result. So 1 is actually identity. So in matrix case, uh, we will not take any real number. So when we are multiplying a matrix A by identity matrix, so we are getting same result. So in this way, either you multiply I into A or A into I, we are getting same result. Like 1 into 5 or 5 into 1, we are getting 5. And last important property, that multiplication is not commutative in general. Why I am saying in general? Because further we will see there are some cases when multiplication is commutative, but I am saying in general it is not commutative. When AB is defined, it is not always true that BA is defined. Okay.